The general form of the equation of a straight line is given as y equal mx plus c, where m is our gradient and c is our y-intercept. We already know what the gradient is, but the y-intercept is basically where the function cuts the y-axis. So if you're given this function graphically, let me draw it. So if this is our straight line, our y-intercept would be at 2, because that's where the function cuts the y-axis. So c would be equal to 2. Now, if you recall, the equation of a straight line is given by mx plus c. That's the equation. And now we know what c is. We know that c is 2, and we want to find m. We already know how to find the gradient of a straight line, right? We find any 2 points. So let's take this point here, and we're going to approximate it at 3 and the y-axis. And we take a next point, say at 6. So at 6, we go up to our function, we go across, we approximate that to 7. So our coordinates here would be 6 on the x, 7 on the y, and our coordinates at this point would be 2, 3. Now, if we use our right angle triangle rule to find the gradient, then m would be equal to 7 minus 3, and we divide this by 6 minus 2, and our gradient would be 4 over 4, which is equal to 1. So then our function would be y equals m. In this case, our m is 1, so 1x plus c, and our c, as we have here, right here, is 2. And we can rewrite this, of course, as y equals x plus 2. Say you have the coordinates and you are supposed to write the equation of a straight line from these coordinates. So our coordinates are at a point P, negative 4 and 4, and at the point Q, our coordinates would be, say, 9 and 15. Remember, our equation is y equal mx plus c. We already know how to find the gradient, so let's go ahead and find the gradient from these coordinates. So we'd have our y2, which is 15, minus our y1, so 15 minus 4, and we divide that by 9 minus negative 4. So 9 minus negative 4. And we're left with 11 over 13. So our gradient is equal to 11 over 13. Now to find c, because we have already found the gradient. To find c, what we want to do is take any point along this straight line, any point. Remember, a point on a straight line would have a coordinate. So this could be a point and this could be a point. Since we already know that these are 2 different points, P and Q are 2 different points, endpoints, then we can use either, or if we add a graph, then we could select any point. So since we have this, we're going to use the 9 and the 15. We're going to use these. What we're going to do is to plug in 9 for x and 15 for y in our equation and solve for c. So let's do that. So y would be 15. Remember, we're putting in this 15 for y and this 9 for x. And our m is 11 over 13. We multiply that by our x, which is 9, and we add c. When we multiply these, we get 15 equal 9 times 11, which is 99 over 13, plus c. Then we subtract on both sides, so we have, let me scroll up, So we'd have 15 minus 99 divided by 13 equals C. This would be equal to 13 times 15. Let's do this way, over 13 minus 99 over 13. And we have that equal to C. 13 times 15, we have 195 over 13 minus 99 over 13 equals C. Now these have common denominators. We can have 13, and 195 minus 99 is equal to 96, and that's equal to C. So 96 divided by 13, let's do this, is equal to 7.385. And that's what our C is equal to. So now, let's rewrite our equation. Our equation would be equal to y, or m, if we recall, 11 over 13. So let's put that. 11 over 13. We put our x plus c, which is 7.385. And since we have a 13 here, let's just write it as this. So y is equal to 11 over 13x plus 96 over 13 for the consistency in the denominator. Let's do this graphically to show it in a graphical sense. So that's what our line would look like. Now, if we recall, we could take any point to find our gradient. So let's take this point here, and let's use the endpoint. We did this in the video that we did gradient in, and we never actually got our gradient. But since this is somewhat of a graph paper, let's see if we get our gradient. So at Q, we already know that these are the coordinates, and at this point we have 3, 10. So the gradient would then be equal to 15 minus 10 divided by 9 minus 3, which would be equal to 5 over 6. Our gradient, when we use these coordinates, was 11 over 13. 11 over 13 as a decimal is approximately 0.846. 5 divided by 6 is approximately 0.833. The more reason I drew this graphically was to show our y-intercept. So if you recall, our y-intercept was 96 over 13, which was approximately 7.385. That was our y-intercept. And if you look here, where it cuts the y-axis right here, let me erase that so you can see, it's approximately at the point we calculated, which is 7.385. And this is how we use coordinates and the graph to write our equation of straight lines. And that's it for this video, so thank you for watching.